This video will show how to set the gap and the proper calibration routine recommended by Brookfield Engineering for our Wells-Brookfield cone plate viscometer. The Wells-Brookfield cone plate is an option available for the DV1 Prime, DV2 Plus Pro, and DV3 Ultra instruments. This configuration is for testing small sample amounts of 0.5 to 2.0 milliliters. To ensure your viscometer is working properly, a periodic calibration check is essential. To perform a calibration check with the Wells-Brookfield cone plate viscometer, you will need a silicone or mineral oil viscosity standard fluid. Mineral oil is the preferred choice for all calibrations performed at Brookfield. It is required for use with cone plate viscometers at viscosities above 5,000 centipoise and at shear rates above 500 reciprocal seconds. You will also need a water bath for temperature control. Select a viscosity standard fluid based on the torque range and model of your instrument and the spindle you will be using. For this example, we will use an LV torque range DV2 Plus Pro cone plate instrument using a CPE-40 cone spindle. The viscosity range for this setup is 0.2 centipoise to 3,000 centipoise, and we will use a B29 mineral oil viscosity standard with an actual value at 25 degrees Celsius of 29.13 centipoise. You do not need to select a standard fluid based on the viscosity value of your material. However, many customers choose to do so as a simple verification. The calibration routine checks the linearity of the spring on the instrument by using one fluid at 3 separate speeds to achieve low, medium, and high torque readings. This checks the linearity of the spring and the sensing mechanism of the instrument. Use the actual value of the fluid for the calibration check. Make sure the instrument is level. One of the most critical aspects to ensure accurate measurements with a cone plate geometry is properly setting the gap. The first step is auto-zeroing the instrument. Turn the instrument on and you will be prompted to remove spindle and press any key. Once the auto-zero is completed, attach the spindle and the cup. To ensure a proper gap setting, allow the cup and spindle to equilibrate for 10 minutes at 25.0 degrees centigrade. Brookfield's cone plate instruments use an electronic gap setting feature. Move the toggle switch to the right and you will see the red light illuminated. If the yellow contact light is illuminated, slowly turn the micrometer ring clockwise as you look down on the instrument until the yellow light is no longer illuminated. If the yellow contact light is not illuminated, slowly turn the micrometer ring counterclockwise until the yellow light first turns on or begins to flicker. This is the hit point, where the pin in the nose of the cone spindle is touching the plate, which is part of the cup. Adjust the sliding reference marker, right or left, to the closest full-scale division mark. Now, turn the micrometer adjustment ring 1 scale division to the left to meet the line on the sliding reference marker. The yellow light should go off. You have established the gap. Now, turn the toggle switch to the left and the red light should go off. For older non-electronic gap setting instruments, the cup and cone spindle have a small pin mounted in the surface of each, which are used to establish the proper gap. Allow the cup and spindle to come to temperature equilibration. Set and start the instrument running at 12 RPM for LV torque models and at 10 RPM for RV and higher torque models. Select the display for percent torque. If the display reading jumps 0.4% of scale or higher, or will not settle to 0, this indicates the pins on the cone and cup are hitting each other with each revolution of the spindle. Move the adjustment ring by turning it to the left, clockwise, until the percent torque reading settles to 0. turn the adjustment ring to the right, counterclockwise, in small increments while watching the viscometer % torque display. Wait at least 6 seconds between movements of the ring. Keep turning the adjustment ring until the display jumps from 0 to 0.5% for HB models and from 0 to 1.0% for LV, RV, and HA models. This is the hit point. Make a pencil mark on the adjustment ring directly under the index mark. On the pivot housing, turn the adjustment ring to the left, clockwise, exactly the width of one division from the pencil mark. The gap is now properly set. With the gap properly set, measure the correct amount of viscosity standard fluid to be used, in this case 0.5 milliliter. The viscosity standard fluid needs to be equilibrated at 25 degrees Celsius to get an accurate reading. In this example, we will be using an LV DV2 Plus Pro cone plate instrument with a CPE 40 cone spindle. Hoses from the water bath inlet and outlet will connect to the corresponding cup's water jacket inlet and outlet for proper circulation. The cup's outlet is the top connection. The inlet is the bottom connection. For proper temperature equilibration, the fluid and cone all need to be equilibrated at 25 degrees Celsius. The viscosity standards are very sensitive to temperature. The embedded temperature probe in the cup of the Brookfield cone plate is accurate to plus or minus 1 degree centigrade. To ensure proper temperature equilibration and accuracy, use a calibrated digital thermometer in the temperature bath. Temperature should be controlled at 25.0 degrees centigrade, plus or minus 0.2 degrees centigrade. The thicker the fluid, the longer it will take to equilibrate. For the 29.13 centipoise value mineral oil fluid we are using, this should take approximately 10 minutes or less. The CPE-44PY cup we are using has an embedded temperature probe which allows for temperature monitoring at the instrument. Based on the CPE 40 cone spindle we will be using, select 3 speeds that will give you a low, medium, and high torque value. With a digital instrument, you can easily find the full-scale range by turning on the motor and pressing and holding the auto range button. For example, if you are using a 100 centipoise fluid, a full-scale range of 200 centipoise will give you a 50% torque. The minimum torque value for a good reading is 10%. A low torque range would be 10 to 30%, a medium range 30 to 70%, and a high torque range above 70%. For this example, we will choose speeds of 2.5, 5, and 10 RPM. This will check the linearity of the spring on this instrument through its full range. Although the equivalent torque ranges will not get us up to 80 to 90%, this is still a valid test which uses the speeds that are available in the instrument. Tolerances for calibration are computed using plus or minus 1% of the actual fluid value for each full-scale range. You can perform a calibration check manually and enter the values and compute the tolerances for pass-fail criteria. Brookfield supplies a calibration worksheet on our website that easily allows you to enter data, computes the tolerances for each range, and gives pass-fail criteria automatically. You can download the calibration worksheet from Brookfield's website at www.brookfieldengineering.com. Going to the link on your screen will take you directly to the calibration worksheet. To see what these tolerances mean, let's look at this calibration worksheet. Enter data in the bold fields. First, enter the spring torque of your instrument. In this case, this will be an LV. Enter the actual value of the fluid in column A. The remaining fields in this column will automatically update, as this value will not change. You can see the 1% fluid value column will update based on this entry. This is the accuracy of the fluid. Enter the spindle code in column D. Again, the fields in this column will automatically update. Enter the 3 speeds you will be running in column E and observe that the 1% full-scale range in column G is updated. This is the accuracy of the viscometer at this measurement range and rotational speed. Now, run the 3 speeds you have selected. Record and enter the data in column I. Your results will show up in the box below. The low limit tolerance is column A, the actual fluid value, minus column B plus G, 1% of the actual fluid value plus 1% of the full-scale range being used. This high limit tolerance is merely column A plus column B plus G. Simply put, if the actual fluid value is 29 centipoise, then 1% of this value is 0.29 centipoise. At a speed of 3 RPM, the full-scale range is 102 centipoise, and 1% of this value is 1.02 centipoise. Thus, the tolerance on the fluid at this speed with the CPE-40 cone spindle would be 29 plus or minus 1.31 centipoise. You can see a graph of your results with this worksheet and the tolerances. Select the Calibration Graph tab to view the results. The data points are plotted and upper and lower tolerances are shown. In this example, you can see the data points came within tolerance. And that's it. You have performed a cone plate calibration check. Remember the important aspects of performing a calibration check. Good temperature control. Use the actual fluid value for the viscosity standard at 25 degrees Celsius. Select 3 rotational speeds based on the associated viscosity ranges that provide low, medium, and high torque readings. If you find the instrument is not within tolerance after performing a calibration check, repeat the test to ensure that everything was done correctly. If your instrument is still not within tolerance, contact Brookfield Engineering or an authorized dealer. A common question is how often should a calibration check be run? The answer really depends on how often the instrument is used. For example, if an instrument is being heavily used, say on multiple shifts, a daily calibration check is best practice to ensure accuracy. Daily usage, 5 days a week, may require a calibration check be performed at least once a week. For instruments used less frequently, perhaps once a month or once every few months will be fine. But to ensure the health of your instrument for many years, return this to Brookfield or an authorized dealer once a year for a full calibration, certification, and cleaning. Thank you for taking the time to watch this Brookfield video. Please check the Brookfield website for new videos that may be of interest. If you have suggestions for future videos that could be of help, please email your input to sales@brookfieldengineering.com.